Okay, so let's jump up to, let me just share a couple of these things with you about what's going on. You guys can all see my screen, right? So, Rob, you have a question still, or you just have your hand up? Okay. Right. So Iceland is this fascinating place where it's very dynamic, right? We talked about this is at the edge of two tectonic plates, and so periodically, those plates are always there's always stress trying to pull those two plates apart, but there's not like open cracks that go down into the Earth's mantle all the time, and so they tend to move relatively very slowly. It's only a few centimeters a year that the plates are moving apart, and that's kind of an average rate of movement. And so the way that happens is literally you form cracks in the plate, and a new rock, melted rock, magma comes up from inside the Earth and fills those cracks. And if the cracks come all the way to the Earth's surface, then we get an eruption. And that doesn't always happen, may not happen here, but one of the things that's interesting about Iceland, they don't have a geological survey the same way that in the United States, we have the United States Geological Survey, and they're in charge of everything that has to do with geology. The U.S. Biological Survey is actually part of that as well now, but the USGS would monitor volcanoes, they would monitor earthquakes, they'd monitor floods. We have one institution that does everything. Iceland doesn't. In Iceland, they have little pockets of distributed information and supervision. So this first website, the enverder.is, this is actually it's called the Met Office. So their main job is monitoring weather, and their main website, if you go to home, the main website actually you'll see is focused on weather. So if you ever go into Iceland, this is actually a good thing to know, because this gives you the forecast for different parts of the country. And that's important in Iceland because, of course, the weather can change very rapidly. And then, what we're interested in is what's going on with this seismic tremor on the Reykjanes Peninsula. And so there are different tabs for all these things. Actually, you can see things about sea ice, climatology, etc. But if we go to the earthquake tab, this shows all the earthquakes in the last 48 hours in Iceland. And you can see, even though Iceland's always tectonically active, like not this active. If you look at the graph down at the bottom, they've had something like 17,000 earthquakes of various sizes in the past week or two, and that's unusual. So this is the map of all of Iceland. This stuff is a bit hard to see at this scale. So for all of these little gray boxes, if you know the name of the box, you can come over here and click on Reykjanes Peninsula, and then it gives you an enlarged map. And this kind of shows you, why, in fact, it's also maybe a good idea that we wait a little bit to go to Iceland, because all these stars are earthquakes over magnitude 4. And so there actually have been some warnings about, rock falls and things like that when this earthquake swarm first started happening, because there are mountains and things in here. They're actually, this is a pretty important place for Dickinson, because Kristen Strock in environmental studies has done some work on some of the lakes that we can't really even see. There's a lake right there, but some lakes we can't even see in here because they're covered by earthquakes. And I've been working for a long time with colleagues, and I've taken lots of Dickinson students to this ridge. This is an area I know pretty well. It's a place we normally go with students because you can see lots of geology. There's actually a little hot springs area right in here that we normally go to. And the dilemma might be, this is Reykjavik, this is Keflavik, and Keflavik is actually the international airport. So when you fly to Iceland, you don't actually fly to Reykjavik, you fly to Keflavik. And from a perspective of the Arctic and our class, of course, this is quite important. This airport was built by the US military in World War II. So Iceland was actually part of the Danish kingdom before World War II and had been for several hundred years. And when Denmark got taken over by Germany during World War II, Iceland declared independence, and the United States and Great Britain very quickly recognized that, and the U.S. built the airport at Keflavik because Iceland is so strategically important to the North Atlantic. And that's why with the shipping routes, this is Iceland's a critical piece. It's one of the reasons why, the Camden Conference, the former president of Iceland was such a big factor in that conference. Iceland is really important, even though it's a small country, even though it barely touches the Arctic. It's strategically in a really important place, and it's got lots of potential resources, fresh water resources, geothermal energy resources. But anyway, so this airport was built by the U.S. military. They kind of got kicked out in the early 2000s. Iceland, as a nation, doesn't really like nuclear arms, and so they ended up. It wasn't like they came and threw people out, but they kind of ended the contract that the U.S. had at the airbase, which apparently now they're talking about renewing. In part because of what's going on in the Arctic and anticipation of a lot more shipping and maybe some different changes in international strategic positions. But anyways, the problem is the airport's here, Reykjavik's here, and there could be an eruption right here. And this kind of eruption is not the kind of eruption that produces like Mount St. Helens explosive clouds with lots of ash everywhere. It mainly produces lava flows and sort of smaller bursts of explosive activity that probably wouldn't be too dangerous. There's not many people that live in this area, actually. There's a little town of Grindavik out here. There's some people that live here. But this area is kind of like a nature preserve in some ways. There's not a lot of activity, a lot of people. But if the lava flows follow the topographic gradients and the lava flows go for some time, they could potentially cover the road. When you're driving from Keflavik to Reykjavik, you're driving on lava flows the whole way into town, and that's relatively obvious. Although they're they're a few thousand years old. So this is a good website if you want to sort of keep track of activities that are going on with this eruption. And another really good website is, let's see. Well, so there are a bunch of things. This is still that same page, but this has aviation color codes. And so these are all the volcanoes that are likely to be active volcanoes or areas. Like at Preston Nuclear, there's actually several volcanoes here, but that's just sort of one location, one area. Green means volcanoes are quiet. Yellow means there's some level of unrest. Orange means there's heightened unrest, and then red means eruption. And so what you notice on this map is there are actually two volcanoes that aren't green right now. And this yellow volcano here is called Grimsvötn volcano, and that is not quite in the middle, but close to the middle of Vatnajökull ice cap. And it's been in a state of yellow for probably the last month. So I was sort of expecting that I've been sort of fishing for invites to go to Iceland when something erupts like this and take my drones. And I worked on the 2010 eruption. I didn't get there till after the eruption was actually over, but it's a complicated process when eruptions happen because lots of people want to go and photograph it. Lots of scientists want to go and study it. So I have my name hopefully on the list, but I'm not probably in the top 10 to get invited, but you never know. But Grimsvötn in particular for me, because I study volcanoes and glaciers, this is the eruption I thought I'd really like to go and watch. This eruption, all eruptions are pretty neat to see if you can view them safely. There are no glaciers here. On the other hand, this triangle just barely covers up, doesn't quite cover up like my field area where I've been working for the past decade, looking at some older volcanoes. So we also would have some interest if this erupts to relate it to what we've seen on these older volcanoes. Anyways, this is a good map to keep checking, and because this, when the aviation color codes are changing, this can have an impact. And even though it wouldn't be volcanic ash spewing tens of kilometers in the air, this kind of eruption does produce a lot of gas and haze, and sometimes the gases are acidic, and so that can also be a problem for jet engines. There is another airport, a local airport in downtown Reykjavik, but usually not many international flights. It's a pretty small runway. And then there is also an airport up in the north in a place called Akureyri. And so there's potential that smaller flights could get diverted to Akureyri if and there's very small airports kind of all around the country, but that would be the next biggest one. So an eruption here wouldn't shut Iceland down for all travel, but it would make travel logistically a lot more difficult. So better to, once an eruption like this happens, a lot of times, even if it lasts a few months, a lot of the initial activity that's disruptive happens in the first couple of weeks. And then it may settle down in kind of a steady state eruption, it's just producing lava flows. And then it would be easier to get access to the country. But we'll have to wait and see. And then the last website I just wanted to point out to you quickly, this is sort of the official Volcanoes of Iceland website. And you can see it's connected to the Met Office, but also the University of Iceland and the Civil Defense Institute of Iceland. And so this just shows you similar things. These are all the volcanoes. They're listed over here. This is a great website because there's lots of information. And you can maybe guess what sort of program is being used to run this website, manage the data. Anyone want to guess? Barb?
A GIS program. Program.
Yeah, absolutely. So this is a GIS program, and you can actually make thematic maps here. So you can show the earthquakes. You can show seismic stations, weather stations, etc. So that's a GIS. This is an online GIS. And it also has, for each of these volcanoes, if you select a volcano, you can go into activity status, although this isn't updated yet for Krýsuvík, which is the name of the volcanic system that's having all this unrest. But there's information in the catalog. It tells you about what the type of volcano is. It has, sometimes you can access map layers. Actually, let's just see what this puts up. Oh yeah. So we can actually, if you click on these things, they actually pop up on the map. So these show some of the volcanoes, some of the different volcanic craters. And then if we zoom into the map, these things should show up better. Oh, maybe I have to have this turned on. Yeah. Yeah. So as you're familiar with GIS, this is some of the kinds of things you can do online. So pretty neat information. Anyway, so any questions about Iceland, volcanoes? If you have questions about the trip, you definitely can, like I said, I'm happy to have conversations with people. It's unfortunate, but not really unexpected. But things are changing quickly in the country. It seems like almost every day we have a new update that they're going to have X many more million people vaccinated, hopefully by May. And so if we got vaccinated, it would make it much easier for us to travel as a group. And so there's by May it would be unlikely that we'd all be vaccinated, but there's a better chance that by the end of the summer, everyone might actually be able to be vaccinated, and that makes a trip like this a lot more feasible. No questions? Okay, so let's move on to the topic of today, sea ice part 2. Did anyone have any questions or problems with the egg code? Can everyone work through that? Yeah. Okay, short. It was a short activity, but it's useful to understand that because, like I said, they use that in many places. Russia has its own slightly different version, So for people that are working on the North Sea route, I actually have a PDF that kind of explains Russia's slightly different version of the egg code. It's relatively similar. It's a circle instead of an egg, and the numbers are slightly different. But there's online keys that tell you how those things work. Okay, so let's talk about icebergs. So as we know, sea ice or ice in the sea can have at least two different origins. It can grow on the sea, or it can be pushed into the sea from land by glaciers. And so in this picture, these bigger, wider ice rafts that we see here, these are probably chunks that are broken off from these glaciers. And you can see here, we've got 1, 2, 3, 4, 5, 6 marine terminating glaciers in this picture today. And like this little glacier, you know, probably 100 years ago or a couple hundred years ago, this glacier probably also came down into the ocean. These glaciers probably, they wouldn't hit directly into the ocean because they would have hit this larger glacier. So certain parts of the world, this is really common. Not everywhere, but this will be an important thing for you guys to think about in your group projects, because if you have glaciers that are marine terminating glaciers along your sea route, this is another thing that we have to be aware of when thinking about these as places for transportation. Icebreakers will always be essential for any sort of travel for the sea ice, right? An icebreaker can go through especially young sea ice. An icebreaker cannot beat an iceberg. Icebergs are too big and thick. So they just have to be avoided. And what I thought we'd do is start off with just a couple of short videos, because this is one of the more incredible processes to actually see. How do icebergs get produced? And we've got 2 short videos that I want to show you. We'll just watch bits and pieces of these, but it's pretty amazing. I've seen a little bit of calving ice. I've never seen, you know, really some of the huge glaciers, but in Alaska, I have seen a little bit. But it's pretty impressive and I think interesting and instructive to actually watch the process of how ice goes from the land to the water. And we probably don't need the dramatic music. So this is called calving. This process of chunks of ice that are attached to a glacier, fundamentally on land, collapsing into the water. So that ice front, for reference, look at that big chunks going, wow. Oh, look at that. Oh, wow. Holy cow. Yeah, this is pretty impressive. Like that was probably a half a kilometer section of ice that just broke off into the water. And the height of this cliff is probably 100 to 200 meters. So that chunk of ice is quite a bit bigger than the boat that these people that are on watching the iceberg fall into the water. There's another piece that's going to go. That pinnacle, it's going to tip over. Okay, so that's yeah. That's probably we can stop there for just a second. So what did you see? Is that what you kind of expected this was going to look like? Did anyone have any? Does anyone have any questions or comments about that? Maddie Z, is this what you were expecting when we started talking about icebergs?
No, not really.
How is it different from what you expected?
I'm not sure. I kind of didn't think they would fall off, I guess.
Okay. Yeah, very, very, very valid, valid point. Sadie, is this what you're expecting?
Yeah, I've seen like videos of that, and when we were in Alaska, when we were in like the Kenai fjords, we actually saw like some parts of like the like glaciers, and well, actually, it was just like a small part, like they were falling, and like they would talk about how like sometimes like boats would get too like the Zodiacs would get too close, and then they'd have to like quick speed away, so like you don't like topple over and stuff. So it was pretty interesting.
Yeah. So in effect, you could actually see that these icebergs, when they fall into the water, they can actually generate tsunami. Relatively small tsunami. They're not huge. But on the other hand, if you're on a little boat, it's all relative. So even a 1 or 2 meter wave might be quite a big wave if you're on a Zodiac. What else do you guys notice about the process? Anybody? What happened? Oh, Jake,
It's
yeah, go
very,
ahead.
yeah, it's very similar to like a brittle type rock failure where it's like failing along existing planes of weakness.
Yeah, so it's a little bit hard to see from that view, but at the ends of these glaciers, if we go back to the if you think back to the PowerPoint, I'll go back there in a second. The ends of these glaciers a lot of times actually have lines going across them if you look down on them, and those lines are crevasses. Those are fractures. And so as the ice is pushing into the ocean, it is already, like Jake said, like it's got a lot of lines of weakness along which it can fail. So last point that I want someone to comment on, what happens, does he describe the process of the chunk of ice? We first start seeing it moving, and all of a sudden then it goes into the water. What actually physically happens to the chunk of ice? John?
Do you mean like it just falls in, or like I'm not
Yeah,
not really
no.
sure. Yeah.
So work with that. But is it like an ice cube that just plunks in the glass of water and sit there and floats?
No, it kind of drops in almost like a piece of rock.
And what does it actually stay as one chunk?
No, pieces break off.
Yeah. Yeah. So when you look at the end of these marine terminating glaciers, if they're actively calving, a lot of times the water, I mean, you still see big chunks of ice, but a lot of times the water is actually covered with what they call melange sometimes. And it's literally, as that iceberg breaks and falls into the water, it breaks up into lots of little pieces. There's still big chunks that survive, but it's not just like dropping an ice cube in the water and the ice cube sort of bobs around, but it stays as one big chunk. In fact, sometimes next time you drop an ice cube into a glass of hot water, and you'll see you get a sense of why that happens a little bit, because if you can visualize what happens when you put an ice cube into warm water, a lot of times you can actually hear the ice cube start to crack, and you can see cracks forming in the ice cube because of the temperature contrast. So that's happening maybe a little bit with the ice, but probably a lot of it is just what Jake pointed out initially, that this ice has already got cracks in it. And so when a big chunk fails, you still get some big pieces that remain as icebergs, but it also, a lot of it just breaks up into really, really small bits. So I have one. Oh, sorry. Questions? Anybody?
Yeah, no, I was just gonna say also it's like different from an ice cube. It's not like it's not a uniform shape when it hits the water. So then you have to account for like the buoyancy of whatever the shape of the ice that it ends up in. So it could, like, we saw that one that kind of looked like it turned over.
Yeah.
In the video, because like the highest part was out of the water, and that's not It's not the like buoyant, the stable buoyant shape.
Yeah, absolutely. So icebergs can be very dynamic, and actually, it's one of the I've gotten to. We did a trip to Greenland a few years ago, and we got to go iceberg watching from land. We were camped in a place where we could see a bunch of icebergs, and you'd hear them crack. You know, you'd be looking out over the ocean, and there are 15 or 20 big icebergs, and you'd hear like this really loud crack, and then you wouldn't see anything, but you'd expect that something big had happened. And then every once in a while, you'd see a crack and you'd see a bit fall off, or sometimes you'd hear a crack and then you just see one start to wobble, because actually as icebergs start to melt as they're floating through the water, bits break off. And if the right chunk breaks off, like Jake said, it changes the buoyancy and the whole iceberg can roll to adjust to its new shape. And so, icebergs are actually dynamic, and they change their shape even after they break off in the ice and they're floating out in the open ocean. That continues to happen. So let's quickly watch one more. This again, we won't watch all of this, but this is actually quite famous. Has anyone seen the movie Chasing Ice? Have you heard of that? Shake your head one way or the other. Chasing Ice. Yes, no, maybe a few people. A guy named James Baylog made this movie, and he actually was awarded Dickinson's Rose Environmental Award 5, 6, 7 years ago. So Baylog actually came to campus, gave several talks, previewed his video. But essentially, he's a photographer, and he set up cameras in front of a bunch of glaciers and had them do time-lapse photography for like 5 or 6 years. And so for a lot of these really active glaciers in 5 years, you can see the glacier changing position by hundreds of meters. Now, he intentionally picked glaciers that he knew weren't quite active, but they caught something that they didn't necessarily anticipate catching, and they actually caught it on video. And this is pretty dramatic. So I'm gonna not mute this, so we'll listen to the sound. I'll try to turn it down so it doesn't blast you. Oh wait, I got to share my screen, sorry. And these videos, even though we're just going to watch bits of these videos, in the PowerPoint for the class, I've got links to these videos. So if you want to watch them on your own time, the links are there. This is pretty amazing. So this is a glacier. This is Ilulissat Glacier on the west coast of Greenland.
Ben, we can't hear any sound.
No sound. Interesting.
I'm pretty sure when you share your screen, you have to enable sharing of sound as well. It's a new feature in the Zoom.
Let's see. Share sound. Perfect. Okay, let's see if this works now. I'll go back here just to. So this is interesting because this event happens as these guys are actually on the satellite phone. Baylog had like some grad students that he paid to go stay in a tent for weeks at a time to watch this. And so this happened actually while they were on a satellite phone talking to him. So let me know quickly if you don't hear this now.
Nothing's happening.
Hey, Jim. It's going well. We had some serious bouts of wind, but other than that, things are fairly well set up here. We've got some continuous time lapse going.
It's starting, Adam. I think. Adam, it's starting.
Oh wait, Jim, this is the big piece is starting to cast. Let me call you back.
Call him back.
Okay, bye.
Still going? Yeah. In that V section right there. Holy shit, look at that big berg rolling. All four are running, right?
Yeah. Look at that. You see how, look at the whole thing.
calving faces 300, sometimes 400 feet tall. Pieces of ice were shooting up out of the ocean 600 feet and then falling. The only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake and peel off and just fall over and roll around. This whole massive city just breaking apart in front of your eyes. We're just observers, these two little dots on the side of the mountain. And we watched and recorded the largest witness calving event ever caught on tape.
Okay, so not to be overly dramatic, I will recommend to anyone, like, wow, when I was getting that in stereo, those sounds are impressive. But anyways, so hopefully now you know that gives you sort of a good visual, like that's what makes icebergs. And you'll see we've got a whole classification scheme for icebergs based on their sizes and shapes and things like that. This is why this is such an important process. You can lose a lot of ice in one event. So from the impact of a glacier, you can get a bunch of stuff in the water quickly. Remember, for this sort of process, this is ice that was sitting on land, and now it's in the water. So this is the sort of thing that changes sea level. I mean, you know, even though that was a big iceberg, I did, you know, change global sea level, you know, fractions of a millimeter, because it's compared to the ocean, it's not that much. But you can see all the water boiling up. You can see, you know, that's a really dynamic place. And in the end, it produces these huge chunks of ice that then start moving in the Arctic currents. And if you're out in a boat in those currents, you want to know where these things are. They don't move, you know, hundreds of miles an hour, but they do move. They can move fast enough that you know, care needs to be taken to avoid hitting them. Oh yeah. So Jake, there's a good thing on Twitter going around a week or two ago where you can go to a website and you can draw different kinds of shapes, your favorite dog or cat or whatever. And then it actually takes that shape and plunges it underwater, and then has it sort of bop back up to sort of show what it might look like if it was an iceberg. I may have a link to that in one of these things. I'm not sure, but anyway, so that's sort of our introduction to icebergs. So let's go ahead and talk about them in a little bit more detail now. Any questions before I jump to the PowerPoint? Okay. So these are our kind of dramatic shots. This is actually a picture I took in same place maybe that Sadie had been, in Kenai Fjords. That's a pretty common place in Alaska that you can go take a boat trip and you can see the ice falling off there into the water. And then this is the Ilulissat Glacier, which is where the chasing ice caught this huge chunk of ice going into the water. So icebergs have made some history that you guys probably know about. You've probably heard about the Titanic. At the time, the Titanic was the largest ship on the ocean, and it was traveling from England to, or the British Isles anyway, to the US, and it was going north because that's actually a shorter path, even though we're not used to thinking about this way. But when you live on a sphere, the shortest way to get from one point to the other is not necessarily what looks like the straightest line path. So a lot of times with both planes and ships, you actually go north and then come back south if you're going from Europe to North America. And the problem is we'll see in a minute, there are currents around Greenland that bring icebergs into the northeast Atlantic. And that's what happened to the Titanic. It ran in the night, it ran into an iceberg. And of course, the Titanic, it was well before we had satellites. So we really didn't have any way to track icebergs except word of mouth reports from from smaller ships that were in the area. So it was really hard to warn people. Here's a modern day concern. This was from a couple of years ago, and it almost looks like it's photoshopped, but it's not. This is a little village in Greenland, and this is a massive iceberg that's floating past the village. Now, they're not worried about the iceberg taking out these rocks. What they were concerned about, the hazard here, was if this iceberg, like there's, you can see the fractures in it, if a big chunk of the iceberg fell off into the water as the iceberg's going past this little inlet, right? Think of the waves that could be generated by that ice falling into the water and coming into this little inlet. Just like when you're out watching icebergs on boats, there are communities that live close to shore, and an iceberg locally could generate a tsunami that could be devastating to a community, especially a community where people live close to the water because they're using boats. Okay, so those are, icebergs aren't also, they're not just sort of scary things. They're also incredibly important biologically. And this is fascinating that we don't think so much about this, but an iceberg, when it breaks off into the water, you have a chunk of ice that's been on land. It's been pushed along rocks that have different minerals in them. It has rocks that have fallen on top of it as it's moving down these glacial valleys. And so when that iceberg falls into the water, it's not just pure ice. It's got lots of other stuff in it. In one way, you could say it's filled with vitamins and minerals. Literally, it's filled with minerals, but small bits of mineral dust. And so as the ice floats out into the water, an iceberg literally becomes an island with its own unique biology and biogeography. And this is something that hasn't been studied a lot, but has been studied somewhat. So as icebergs float, if they're not too steep, they become platforms. Seals love them because they're out in the open water, so that's safer. It's harder for bears to get there, etc. Sometimes polar bears get trapped on sea ice or icebergs, and they actually get transported to faraway places. So periodically, there's a polar bear that pops up in Iceland every couple of years, even though Iceland is further south than the normal range of the polar bears. And generally when that happens, it's because a bear has kind of got stuck on an ice floe or an iceberg that took kind of a wide drift coming out of Greenland and ran into Iceland. But as this ice melts, there's all kinds of minerals that get released into the water, and depending on what's in those minerals, they can act as fertilizer for the ocean around the iceberg. And as the iceberg's melting, of course, it's also adding a lot of fresh water to the local environment, which also changes the chemistry of the ocean and can release minerals or be a favorable place for different kinds of animals. Now, a lot of this is microscopic organisms, but in the oceans in particular, those microscopic organisms, like things like krill, which are tiny, they actually are the main food for baleen whales. So there are some of the largest, in fact, the largest animal on Earth, the blue whale, is a baleen whale, and it lives by eating these tiny microscopic things that live in the ocean, and it just eats vast quantities. So icebergs are fascinating. They're important for lots of reasons, and so it's something that we want to understand and we want to kind of check out. And so as you're working on your group projects, you can start with Google Earth as sort of a quick and dirty satellite set of images that you can zoom in, and what you're looking for, if you're interested in figuring out, are icebergs going to be a problem on these shipping routes, what you want to look for are glaciers that are marine terminating, because a lot of glaciers aren't. But we'll see in a minute. There are some places in particular that have sort of high concentrations, and those are places where iceberg watch monitoring is going to be important for shipping. So we already talked a little bit about this, ocean currents. We have warm North Atlantic current that comes in. Thank you, Susan, for the article. Some of you saw that. Actually, Barb sent an article a week or two ago that I should have posted about Yellowstone and microscopic life. But Susan sent an article. One of the things that's starting to happen, unfortunately, with climate change, and this will have a big impact on the Arctic and Northern Europe, as a lot more fresh water goes into the Arctic Ocean, it's actually changing the ocean currents. And a big concern is it's going to slow down and change the direction of this warm water from the North Atlantic current. And if this warm water becomes cooler, even though this is happening because of global warming, one potential impact is that this part of northern Scandinavia and even down into Great Britain all of a sudden gets a lot colder because you don't have heat being transported up in large volumes from the North Atlantic current. And so that actually could have an impact on the sea ice that's non-intuitive, right? We're thinking about the sea ice is getting less and less every year because of global warming. But if this North Atlantic current shuts down, then all of a sudden we don't have this warm water coming up nearly as far, and that actually might change the dynamics of sea ice along this North Sea route at the western end. Right, so ocean currents are really important for thinking about energy dynamics. But then, of course, for what we're talking about today, they're important for how icebergs move. There are currents that go up the east side of Baffin Bay where there are lots of glaciers, and the icebergs can get pulled up. But eventually, the stronger currents actually come down the west side of Baffin Bay, and they come down into the Labrador Sea, which empties into the North Atlantic, which is full of container shipping and other sorts of shipping traffic. So this is like tracking icebergs is important enough. I found this online. This is actually a private company that you can pay to get access to their satellite data for tracking icebergs if you're a shipping company. I'm sure they hired GIS people. So this is another reason why we're getting GIS skills, right? So these, and then this map below, this simply shows these are locations of particularly large icebergs that are being tracked. And you can see they come down, you know, through the Labrador Sea and basically out into the North Atlantic. These red lines are different shipping routes that people take to go, like this is going, can I get my geography right here? Yeah, this line's going to France. Here's the UK. This is going to Norway, and this is actually going to Spain and Portugal. So all of these shipping routes intersect this part of the ocean where you can have icebergs. Why do we have a lot of icebergs in this part of the ocean? This, you guys are familiar already with your past activities with Greenland a little bit. And this is a series of maps. This paper is not necessarily about icebergs, but basically where you see all these big dots, those are places where you're losing large amounts of ice mass from the Greenland ice sheet. And so the fastest way that you lose ice mass is not by melting, it's by calving. Because as we saw, you can get rid of a huge volume of ice in 10 minutes if you have a big calving event. And so all along the southeast coast and the west coast of Greenland in particular, we have big glaciers that are marine terminating glaciers, so they can produce icebergs. On the other side of Baffin Bay, actually, and this is one of the reasons why, especially for the Northwest Passage, this is really critical, because all the Northwest Passage routes come out into Baffin Bay. And Baffin Bay is sort of like Iceberg Bay in the summer. And partly it's because of all those glaciers in Western Greenland, but also on the eastern side of Baffin Bay, we have lots and lots of marine terminating glaciers, as you can see on this map. This is Prince of Wales ice field on Ellesmere Island. This is Devon Island down here. Ward Hunt Ice Shelf is right here. Dickinson alum Will Koch-Titsky is actually doing some of his PhD work on Ward Hunt Ice Shelf. We've actually taken trips to a place called Alexander Fjord, which is right here. The glaciers in the fjord don't actually hit the ocean anymore, so they're not producing icebergs, but the glaciers just on the other side of the mountain from where we were produce icebergs. And this just shows, again, with these currents, because the currents move past all these marine terminating glaciers, they can pick up icebergs and then eventually take them down into the North Atlantic, where they can get potentially picked off into the Gulf Stream even, but certainly cause lots of problems for shipping routes off the coast of Canada. Okay, so one of the things that you guys will want to do and need to do is spend some time in your groups. And like I said, I would start off in I'd start off probably in Google Earth because it's the fastest way to quickly zoom in on places where there are glaciers. The maps aren't always the highest resolution, but like, you know, for people with the North Sea route, does Novaya Zemlya or any of these glaciers on this big island marine terminating glaciers? Because if they are, they could produce icebergs. You got Academy of Sciences Glacier on Franz Josef Land. Again, are any of these producing icebergs? Svalbard. Once we get to the North Polar route, you definitely, you know, that route goes right through here, which is kind of one iceberg alley. For the Northwest Passage, not so much worried about icebergs in the western part, but once you start to get in the Canadian archipelago, icebergs can get trapped in here. And certainly as you're trying to come out the western or the eastern end of the Northwest Passage, you got to navigate through Baffin Bay, which has got a whole lot of different marine terminating glaciers that can produce icebergs. So this will be critical stuff for you guys to think about. Okay, I think what we're gonna do, so I'll get the video uploaded and I'll upload this PowerPoint. Most of the rest of the PowerPoint is just going through a little bit about different sizes of icebergs. So you can watch that. You don't need me to sit here and say, you know, read the text from the screen. This is a flat iceberg. See, the sign says flat iceberg, there's a picture. You guys can go through that on your own. So it'd be more efficient use of your time maybe for me to stop here. And what I'm gonna do is give you sort of 5-10 minutes to ask questions if people have questions. And if no one has questions, you guys can dive into your groups and start talking about where you might want to do some checking for looking at icebergs along your routes. And I do the other thing I want to add here as a kind of as a question to you guys. I don't use Microsoft Teams a lot, but apparently I'm going to start using it a lot more in the near future. And it is sort of convenient. Has anyone used Microsoft Teams? Yeah, a couple people have. So what's nice about it, one, you all have access to it through your Dickinson accounts. You can drag and drop files onto it to share. So it's kind of like, it's almost like a private Moodle, but it's a little bit simpler to use. And one of the nice things about Team is when you're in your team, like you can chat if other people are logged in, but you can also quickly click on a little thing that will automatically put you into a video call. And so I'm wondering if this would be a useful tool for your groups. I don't want to add technology stress if no one's interested, but if you think it'd be a useful thing for your groups, I can set up a Teams for each group that you guys can use to share. Like I said, you know, if someone's got a picture they want to share or anything, you literally, if you got your Teams window open, you can just grab a file from your desktop or another folder and drag it into the Teams files and it'll upload. So it's a pretty easy way to share. Does anyone have any interest in that? I can also set, I mean, it just takes me like 2 minutes to set a team up. So I can also set the team up, and if you guys don't want to use it, you don't have to. Okay, maybe I'll do that, and then you guys, you'll get an email invite when I add you to a team, and you just have to respond to that, and then you should have access to that team. But I'll try setting those up, and it's just, if you want to use it, you can. If you don't, you know, you definitely don't have to do it. It's not a required part of the project, but it might make it easier to save stuff. Okay, so no geography quiz next week. You should be working on, you know, your individual projects. You should be working on your group projects. We'll do group project presentations. My plan was to do it on Thursday. Although maybe I'll do a quick email survey and just make sure that works for people. And the idea is that as a group, I just want you to share a little bit of information with the rest of the class about your area. So this is very, very preliminary. Things you might want to share are things like good websites. Did you find a website that's a great website for tracking icebergs? That might be useful for other people. Did you find a great website that has graphics showing the distribution of different whale species. A lot of the basic GIS stuff that you guys might be wanting for your group projects are in the layers I've already given you. There's geology, there's permafrost, there's etc. But you may want sea ice information. You may want some climate change models. Maybe you and that kind of stuff. What I will tell you is you do not have to do that on your own. If you want to, go for it. There's lots of stuff you can explore. But if you'd like some, for example, some predictions of climate, of temperatures going out the next 50 years, if your group just says, hey, Ben, we'd like some of this data, I can either train one of you, or I can just jump on quickly and download the data and send it to you. And I'm happy to do either. You guys just have to communicate with me and tell me if you want help or you need help getting the data. Okay. So any questions? Oh, Sammy?
Yeah, I have a quick question. So if we're presenting on Thursday, how long do you want each group to kind of present? 5-10 minutes, max 15, or what are we thinking?
Yeah, so we've got 4 groups. So if you each did a max of 15, then we could do that in our hour 15 minutes. Yeah, that's good. So max of 15. And if you take less, that's fine too. But I just want you guys to give me a little bit of an update on where you are. What are your challenges? What are some things, like I said, some places you need help? What are some good websites you found that are really useful, that might be useful for other people? You guys all either go in or come out of the Arctic in the same spot, because they're really only 2 ways. Oh, Northwest Passage, that's not quite true, because I guess you come in through, you miss Iceland, because you come in through Baffin Bay, so you're on the west side of Greenland. But all the routes go out through the Bering Sea. And so for your groups, we have a Bering Sea specialist group. So once you get to the northern edge of the Bering Sea, you guys don't have to go any further. If you want to go a little bit further, you can, but you don't have to, because we have a group that's going to just be focused on the Bering Sea. Yeah.
And one other question. So is this just like a update on where we are with the group project, or is this the finalized group project presentation?
No. The finalized group project presentation you're going to do basically during finals week. So you've got a whole other half semester, right? I just want to see kind of where you guys are with progress. And so I don't expect you to have like 2/3 of your presentation done. I mean, if you're gung-ho and you have, well then, great for you. Your second half of the semester will be less work for this class. But I'm not anticipating that at all. Yeah, so it's really just kind of a first update to let me know about challenges, problems, like I said, share resources. But I want to see that you guys are sort of engaged as a group in the process of gathering information. And maybe explain your organization a little bit if you have it. Like I said, in the past, some groups have had one person really keen on geology, so they become the geology person, and one person's really keen on permafrost, or one person's really keen on sea ice. You don't have to do that. But if you want to, if people want to organize things that way so that everyone kind of has one thing to focus on, that's fine. Good questions. Anything else? Okay, so focus on group project and individual project progress. I think Tuesday we'll sort of wrap up the physical world. So I want to talk a little bit about permafrost, because that's also potentially important along shipping routes. If you've got permafrost that intersects the ocean, that can have an impact on, where you can build ports, where you can put infrastructure, and even permafrost instability on seashores can impact that. So, and I will have, I've got Arctic data sets of permafrost. And so I'll probably build a sort of reduced size OneDrive folder on permafrost that you guys can all access. But we should talk about permafrost a little bit. So we'll do that Thursday. And then in spring break, after spring break, we'll come back and we'll focus on the biological world. We'll get a little bit of ecology, first non-human, Then we'll go into human ecology and carry on. Okay. And I'm around Friday. So tomorrow, anyone who wants GIS help or anything like that, give me a shout. And we can do some more stuff. Doesn't have to be GIS. If you have questions about individual projects, if you want to talk about global study program and what may happen with the trip, etc., you know, just send me an email. Okay. Okay. Anyone has any other issues as well? Like, I'm always available to talk. If there are other things going on, not related to class, but that you feel like you need to talk about, why, just let me know. Okay. Well, I'm going to give you, gosh darn it, I thought I was going to finish early. Sorry about that. But I will, yeah, we'll finish right on time today. And if anyone has questions, just get a hold of me. Oh, yeah, how long, Sammy? Okay, yep, okay, I think I got the chat. Okay. Have a good weekend. I'll see you guys on Tuesday.
Thank you.